So what I want to do first is I want to highlight the fact that government, in order to get this improvement in market welfare, the government has to pick the right tax level, has to pick the optimal, ideally, or at least it has to be close to the optimum to assure that you're going to get an improvement in market welfare as a result of the intervention. What I want to do for a minute here is just take a turn at this question. What if we overtaxed? What if the government determined that the costs of pollution were much higher than they really were, and they put too big of a tax into place? Okay, what would that do? Okay, so I got here. Although a tax on polluting activities can cause a welfare improvement, getting it right depends on measuring the costs and benefits. Okay, that's what I just said. All right, so let's consider the following effects. Let's set the tax, T2, greater than the optimal tax. The optimal tax is the one we just evaluated, the one that gets us to Q social. Well, let's do another exercise, and here's the diagram again. But notice that T-opt here is smaller. It's this distance. Oh, I got it right there. And T2 is a much bigger tax. And we're going to say, well, what happens if you put the much bigger tax into place? Okay, now, the deadweight losses, the welfare effects of the optimal tariff. Remember that the deadweight losses are A plus B, negative. I'm going to put the negative, it's deadweight effects, we might say. The loss then becomes redundant with the negative sign. Okay, so the deadweight losses are going to be A and B. And the change in the externality effect is going to be a positive, like I said before, A plus B plus C plus D. So it's this rectangle right there that generates the benefit that's going to arise in this graph from setting the optimal tax at T-opt. And that's going to give us a change in market welfare. The A's are going to cancel out, the B's are going to cancel out, and we're going to be left with another way of looking at this is going to be a plus C plus D. Okay, so the welfare effects of the optimal tax is C and D on this diagram, which, by the way, is going to be equivalent to this area right up here, which is how I depicted it before. Now let's take a look at the welfare effects of T2, the bigger tax. We put the bigger tax in place. Well, now the deadweight losses are going to be given by, I'm going to just write it this way, the red area. Because what's going to happen is at a tax T2, notice area B corresponds to the production efficiency loss, but that area B is going to extend to this whole area when you expand the tax to T2. And consumption losses, the consumption effect A is going to expand to this whole area here. And so the total deadweight losses are going to be negative the red area. So the red, again, refers to the negative effects that are being caused by the tax T2. Now the positive effects, the externality effects, is going to be the green area on the graph. Okay, and that's going to be the positive because now you're cutting production by a whole lot more and you're eliminating a lot more pollution as a result of that. And that's going to be good for the people who were negatively affected by pollution. But you're going to be achieving that benefit for them by hurting others in the market to a greater degree. So if we said, what is the change in market welfare? That's going to be equal to the green minus the red areas. The greens are going to be the positive effect of reducing the pollution. The red is going to be the negative effects, the deadweight losses that you're causing by the tax. And if you take the green minus the red area, what are we going to end up with? We're going to end up with a C plus D minus E minus F. Because this area in the middle overlaps each other, so that's going to cancel out. The E and F are both negative areas, causing harm to the economy. The little c and d correspond to positive areas being created that are left over. And so we add them up together, c plus d minus e minus f. From the graph, I can look at that and see I've set a tax that's big enough so that on the graph, I can see that that's going to be negative. But it's going to be dependent in general on how big that tax is. The closer T2 is to T-opt, the more likely it's going to still be in the positive area. But if you put that tax up too high, you're going to end up with a picture like I'm showing here, where the deadweight losses are going to overwhelm the positive improvement in well-being to those who were affected by pollution. And you're going to end up making society worse by putting the tax into place at the wrong level. Okay, so here's a problem we have to be aware of. So we can make the principled argument that government can indeed intervene and improve the market outcome when there's an externality effect present. But we have to be careful that the government gets the policy right. They've got to be able to set that at the right level in order to assure we're indeed going to get the positive outcome. It's not any tax that will benefit the country. It's not any kind of government involvement. It has to be a tax set at the level that's going to generate the socially optimal outcome. And the only way to be sure you can get that is to be able to measure these costs and benefits really effectively. Okay, now, I want to point out this last thing. The optimal solution then has to balance the costs of pollution with the benefits of providing the product. What this is also showing us is that zero pollution is not the best outcome. Okay, zero pollution is going to, you can get to zero pollution with a big enough tax. If I put a tax into place equal to this level right here, I could stop activity in this market completely. We could stop using gasoline. We can stop driving our cars around or be forced to use, battery-driven or alternative methods of transportation. It is possible to eliminate the pollution completely with the appropriate tax. But in this diagram, given our measurement of social cost here, that wouldn't be the ideal outcome because it would be too costly. We wouldn't be willing to give up that much of our day-to-day pleasures in using gasoline to try to get to a zero level of pollution. So zero pollution is not the societal optimum. It is the best for the people who are affected by the pollution, but it's not going to be beneficial for everybody overall. Okay, and that's something we should be aware of. We don't necessarily want to get rid of or need to get rid of all pollution. We just have to get it to a level that's manageable, that balances with the benefits we're getting on the other side.